Okay, chapter 3. Hey guys, settle down. Chapter 3, exponential and logarithmic functions. Darby. Y equals a b to the x. That's your exponential function. That is not a logarithm. A log says log in it. So it's called an exponential function because your variable is in the exponent instead of down where the a or the b are. The a, this is the initial value. So it's whatever amount you start with. The y is the amount after x units. X meaning the x that is the exponent. So maybe it's time. Oftentimes it's time. Like you will do, if it's a growth, maybe it's a population growth, and your x will be like in years. Maybe we're getting ready to do one with bacteria, and our x is going to be in seconds here. And the initial value will be about the bacteria and stuff. So we'll say x is whatever the units are. Let's say generally time. So you're going to have a problem on your homework today where it's about music and it's octaves. So so that it doesn't always have to be time. And b is just going to be some number that we find in each case. And all right, let's look at number 1, certain food. In this case, it looks like it's a hot dog.
Yeah.
Yeah, you should write this down. This will help you with your homework. B is a number that we're going to be solving for each time. It's going to be different. Yeah, you can copy the problem down now.
You feel a little bit more secure about it. No, I thought it was you. You did?
Call your mom. Mr. and Mrs. Sapp.
Okay.
This is
I thought it was funny that one time at the meeting that like right after you started recording, you're like, oh, you know, we're recording. Try to turn around. Okay.
yeah.
Smiley face, broken hearts.
They're going to be here. Like, no, this is interesting. What are they doing right now?
Maybe I'll pause while you guys write them down.
Yeah.
Yeah, because then they can hear all the stuff in the background. Like, I wish I was there.
I've been eating
Okay, a certain food is dropped on the floor and is growing bacteria exponentially. These graphs, by the way, when we talk about exponential functions, they start out kind of low and then they increase very quickly. So that's what, and we'll be graphing it in a little bit too. But when something grows exponentially, it's going to grow quickly. Not at first, but pretty soon it'll start growing quickly, like your retirement funds. The earlier you guys put money into retirement, here are the golden years. Right before you retire, your money is going to grow so fast. So I wish I were a little bit more wise when I was younger, and if I had started my retirement a little bit earlier. But anyway, tip to the wise. Okay, if there are 2 cells initially and 30 cells after 2 seconds, find the growth equation. All right, so we're going to start with A, the initial value.
2.
There are 2 initially.
Oh.
Okay, now 30 is the amount after how long?
I see it. 2 seconds.
2 seconds, so B to the 2.
Was it where you switch them and they go?
No, I don't think so. Okay, now we solve for B because we need to figure out what B is. So divide by 2, and you get 15 equals B squared. and then you grab your calculator, and B is going to be equal to 3 point what?
3.87.
Give me 3 decimal places.
873.
873. Okay. So our growth equation is going to be y equals 2 gets to stay. It's just the x and the y that are going to be variables. So 2b is going to be 3.873 to the x.
We don't,
X and y are still your variables. You just replace the a and the b.
do you not combine 2 and 3.87?
No, you can't, because the x is only for the 3.873.
Then Miss Keating, what's like Miss Prosach taught us where this form and like the X is found?
No?
Gators.
I'm not going to record you guys if you continue doing this. Here we go. The 5-second rule says that if a person who drops food on the floor eats it within 5 seconds, there will be no harm. How many bacteria are there or are on the food after 5 seconds? Well, we need our equation here. And for us, our time is the x, isn't it?
So it's 5 seconds.
So we're going to change it to y equals 2, 3.873 to the 5th.
Oh, so you just plug in that to the...
Mm-hmm. Okay, and then on your calculator, you know how to type that in, right? Should be a pretty big number.
1,742.8. That's a lot of bacteria.
0.8? That's a lot in 5 seconds, isn't it? Yeah, definitely not.
Really, like, having like right there.
Would you eat a food? No, I wouldn't.
I wouldn't eat a hot
Q-tip would eat it, though.
Eat it. Yeah.
No way.
Jose. No way, Jose. With a little accent on the E. Yeah.
Okay, there you go.
Yes way, Jose.
Okay. Whoa, whoa, whoa.
Are they going to
We
be
need to.
more problems like this?
There you go. Yes, they're going to be word problems like this. That's why I'm making you write them down. Okay, pausing for. Okay. So the population of Nigeria has declined from 3.4 million in 2000 to 2.3 million in 2010. Right, an exponential decay function because we're decreasing in population for Nigeria. So our initial population, I'm going to go down here. Our initial population is 3.4. So we'll just put 3.4. You don't have to add all the zeros and stuff. Okay, and then it declines to 2.3 after how many years? 10 years.
Wait. Oh.
We're okay?
So how do you divide 2.35?
Wait. Hold on, guys. Chrissy?
You wouldn't just put 1 year, you have to put how many years?
Yeah, because we started in you could, okay, so if you did use 1, then for part B here, what would you use? If it's 20, it'd be 2, because you're going every 10 years. You'd get, yeah. So, okay, let's go ahead and figure out what B is. Divide by 3.4. Somebody give me a decimal for that. 676 equals B to the 10th. If you want to solve for B, then you need to take it, the 10th root, or to the, and the same thing as taking the 10th root is taking it to the 1/10. So either one will be good.
So if you do like to the 10th, it's 0.962.
0.962? Thank you. Okay, so here is our exponential decay.
I got
963? Is it rounding?
it's 0.9616. I got 0.96301.
Wow, okay. So, okay, so it's 962. Okay. Hey guys, come on back. Okay, so y equals 3.4 gets to stay, and then my b turns into 0.962 to the x. So there's my decay equation.
Oh.
And look at this. Here's another way to know that it's decay. When your b is greater than 1, 3.873 up here, that's going to be exponential growth. It's going to actually grow But when we get something that's less than 1, a fraction of any sort here for the b, then that's going to be decay and it's going to be coming down. Okay, use your equation to predict the population in 2020. That means my x is going to be 20 now instead of 10. Because now 20 years have passed.
What you just found, or?
I do. Yep. Y equals 3.4.962 to the 20th power.
1.567.
1.567, so we'll round to 1.6, right? And it's million. Is that a reasonable answer? 3.4 to 2.3, now we're down to 1.6. Yeah, that's a reasonable answer. Okay, and when will the population reach 1.2 million? What do I do with 1.2? What's that going to be? That's your y, exactly. Good. Okay, so it's going to be 1.2 equals 3.4? Yeah. 3.4 times 0.962 to the x.
So you don't know.
Right. Okay, the first thing you have to do to solve for x is you've got to get rid of the 3.4 first. So let's divide both sides by 3.4. And
0.353.
353, okay. So now we just have 0.962 to the x. Now, do you remember how to get the x down out of the exponent? We have to do something to both sides.
1 over 2, 1 over 10, 1 over 11.
We actually take the log of both sides. And that, one of the properties of logs is that I can, if I take the log of a number with an exponent, I can bring that exponent down in front of the log. So, to solve this one, it'll be log 0.353 equals x times log of 0.962.
Wait, explain that one more time.
I'm bringing this, if I take the log of anything and it has an exponent, I can take that exponent and bring it right down in front.
So it's log 3.53 divided by log 0.962?
Exactly.
Yes!
All right, so we're going to divide both sides by, because log of this number is just a number.
No, that's probably crazy. So then we have to actually do the log or so, right?
Yeah, we're going to actually, when you type it into your calculators, let's make sure we all get the same answer. If you have parentheses, then you need to close the parentheses before you hit the divided by symbol.
Or if you have one of these, you can just do those.
Yes, you can just do it like that. Yep.
Okay, tell me what you get for that one.
I'm getting,
26.87. Yeah, 88.
that's it, 26.88.
What do you suggest we round these to?
Let's see, what's a reasonable? This is what, when will the population, oh, we're talking about time. So it's going to be in,
27 years.
yeah, 26.878. So it'll be in 2026 is when it will happen during that year. Okay?
Oh, okay.
It'll happen between the beginning of 2026 and the beginning of 2027. So sometime in that.
So we're going from 2000 to whatever we get the answer for, right? We're not going
Yes.
to 2022.
Your initial, we started at 2000. Yep. So we add that to 2000. Okay, that's the hard stuff. Let's do the easy stuff now.
Oh.
Well, the word problems. That's why. Okay, with the same axes, sketch the graph. There's not much to these. I only require 1 point on it. I only require 1 point, but you're welcome to put as many points on it as you want to. Sometimes, at least in the beginning, it's difficult for you to remember what does what to the graph. So you might want to plot a couple points and see which way the graph is heading. Is it going up? Is it going down? These?
Okay.
Yeah.
You can have them. I mean, you don't need it because you're only going to do 1 point. It's pretty easy stuff. So, if you want them, though, they're right here. And the double-sided tape is there, too. Okay, we ready? Y equals 2.5 to the x? All right, if I were plotting points here, let's pretend we're doing a t-chart. X, Y. If I put in an easy number like x is 0, what is 2.5 to the 0 power?
0.
Whoops.
I mean, whoa.
1. This is the point that I want you to put on there.
How does it get 0?
I just plugged in 2.5 to the 0 power. Anything to the 0 power is 1.
0.
Okay. Okay, so we have 0, 1. This graph has an asymptote. No matter what x value I plug in there, whether it's positive or negative, it can never be, 2.5 raised to any power will never become a negative number. Therefore, it has an asymptote at 0. It will never be equal to 0. It will never be a negative number. The only way I can make this graph appear below the axis is if I actually move it around with, like adding numbers like this and stuff like that. So we're going to draw my asymptote right here at 0. And this is an exponential growth equation because 2.5 is greater than 1. Whoops, I don't want to do that. Undo. Here we go. So it comes in from the bottom, goes through my point, and heads up quickly.
And it's not level with the asymptote.
Correct. It never touches the asymptote.
So that's all we have to do.
That's all you have to do.
And it's always going to be what?
That's the 1 point you have to put on there. Yep. Until
So is the graph for each one of these going to be the exact same?
0, 1, 0, almost.
Well, except for the negative x.
Because remember when we had that, for Nigeria, we had a number that was less than 1, so it's going to be coming down. It's a decay. So I'm going to,
Wow.
yeah, I'm still going to have my asymptote. I'm still going to have a point at 0, 1, because if I put 0 in here, 1/2 to the 0 power, ladies and gentlemen, is still 1. However, it's a decay function, so instead of coming in from the right and heading up, it's actually coming down from above and heading to the right.
Wait, how do you know it's a decaying?
Because the b here is less than 1. It's 0.5, 1/2.
Wait, so question, how do you know that's the B? Like, wouldn't that be the A? Or is that the B and the A combined?
No,
You can't do that.
the b is the only one that gets the exponent.
So whatever, even if there's an A in front of, like, if it was 2 parentheses 0.5, it'd just be 0.5, and
It
you
would
only
just be
worry about
0.5.
that.
Yep. Okay, let's talk about this last one for just a second. Do you remember what happens when you have a negative exponent, what it does to it?
What's it?
It flips it, exactly. So instead of this 1/2 to the negative x, let's flip it, and it will be actually 2/1 to the x. So is it exponential decay or exponential growth? Growth, yeah. So if you have a negative exponent, it's going to, it actually is going to make it decay, but if it's less than 1 and it's negative, it's like it made it decay and then it made it growth again. Whoops.
That was a parabola.
No. Okay, and this point is still here because if you put a 0 in for the x, you're still going to get just 1. Question? No. We don't deal with b as 1. Never really. You'll never see that, yeah. Okay, now we're going to talk about logarithmic form. This is it. This is the switchy stuff. Well, I call it switchy stuff. There's an echo in here. Okay. Write each in the form y equals b to the x. So the first one we have log base 2 of 8 equals 3.
Oh, hi. Sorry, all kind of
Okay, what I do is I tend to, I call it switching. It's kind of like a basketball hoop. I don't know why that happens in my head. It just does. And I start down here at the base, and I come around the equal sign, and I catch that 3, and then I swoosh right into the 8. 2 to the third. Whoops. Let's write that again. It's going to be 2 to the third equals 8. 2 to the third equals 8. Always start with your base.
Do you take all the laws?
Yeah, it's gone. 2 to the third equals 8.
That's it. Wait.
That's it.
I thought 280 was like, wait. And then once where you bring it back and you don't bring the laws.
Okay, let's do the next one.
So we know what the answer is now. It's log 3.
All right, let's go ahead and write number 2 in log form. Start with your base. Let's see. X to the first equals 5. Yep, if we were solving it, that's what we would do. And the next one, log base A of B equals C. So we'll start with the A to the C equals B. A to the C equals B. And we do the same thing with writing them in logarithmic form. So we start at the base. We're going to go around the equal sign and switch. So it's going to start with log. The first number will be x, your base. Then 64 comes next, equals 3. Your exponent is always what the log equals, because the log is an exponent. Okay, let's go to this one. Start at your base. Go. Wait. Okay. We're good? Okay. Log base 2, go around your equal sign and end at your exponent. Log base 2 of 1/16 equals -4. And you know, you can always just switch it again and see if you end up with your original. 2 to the -4 equals 1/16, and that's what the original was. Okay. Again, start your base, x, z, and then y. So it's going to say log. X will come next, then the z, and last is your y.
That kind of just like help us know how it's going to work.
Yeah, it's just a little trick. Yeah, when you guys are on tests or quizzes and stuff, and you're like, I don't remember how to do this, and I'll just say, just switch it, and you'll be like, I know what to do now. It's a weird little thing, but it helps you remember. Okay, we're going to evaluate these. That means we are actually going to find the number that it equals. So what we want to do is, what I think is easiest, is I just say this equals something. Let's say it equals x.
Oh, and then you do.
And then I switch, and then I find x, yeah. So start at your base, 3 to the x equals 27. 3 to what power is 27? To the third, yeah. And you can also write like this. Some students like doing this, writing it with the same base first, and then saying that x equals 3, because, remember that? Yeah. So some of these are really easy and you'll know immediately. Some of them are a little bit more difficult and you might have to finagle it a little bit more, like I did in the middle step here. I do. I think it's easier to see it, because it's easy, once you set it equal to something, then it's like, oh yeah, I just switched it, I know what to do now.
On
Maybe?
these calculators, there's a form where it's just like log 3, 181.
Yeah, you can do that too. But if you don't have a calculator on the test, then you'd have to be able to do this.
Do we not have calculators on the test?
Sometimes you won't.
What?
Yeah.
All right, well.
Mental math. 3 to the x equals 1/81. Okay, so now, whoops, let me move this out of the way, because I think I need more room. Ooh, hold on.
Yes, Oh, yeah, I know, I was just.
Okay, here we go. I want to write these with the same base, and I heard somebody say we need a negative exponent, and that's exactly what we're going to do. 3 to the x equals, now this can be written as 3 to a power, but first I'm going to go ahead and rewrite it as 81 to the negative 1. 3 to the x equals, 81 is 3 to what power? Somebody said it. 4. It's 3 to the 4th. 3 to the 4th to the negative 1, you're just going to multiply. It's going to be 3 to the negative 4. X equals negative 4.
How do you know?
How do I know what?
Like, I don't even know what's happened. Like,
How do you like just know that? To work it out.
You just keep dividing by Eden. 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 Pay attention to me. Okay. You know, because here's a base. You have no other base that you can possibly use. For instance, this does not say 9 to the x. You could either use 9 or you could use 3. This is just 3, so this has to be written with a base of 3. So you just start dividing by 3. And then you'll find out if you divide 4 times, you'll get it. And so then it'll be 3 to the 4th. Okay, let's do number 3. Let's say it equals x. We're going to switch it. 5 to the x equals 125. X is 3, yeah. Because 125 is 5 to the 3rd. So the answer is 3. Okay, let's do log base 6 is 6. Start at your base, and you'll switch it. 6 to the x equals 6. Exactly. X is 1. Two more. These are going to be long, I think. We've got log base the square root of 3 of 27 square root 3.
Okay.
It looks scary, doesn't it?
3 to the x equals 27.
Yeah. Square root of 3 to the x equals 27 square root 3 when we switch it. Okay, what we're going to do is we're going to change all of these into bases of 3. What is my power for the square root of 3? 3 to what power?
1 over 2.
1 over 2, right? The power, your power is your exponent 1 here because it's just 3. And then your root, which is 2, goes on the bottom. Power over the root. So it's going to be 3 to the 1/2 to the x equals 27 is 3 to what power? To the 3rd. Okay, so 3 to the 3rd, and that's times 3 to the 1/2. Okay, now this is a little bit easier. When I take a power to a power, 1/2 to the x power, what do I do with these two? Do I multiply or add? I have to add them. No, I'm not. I'm sorry. We have to multiply them. I got distracted by Will. Okay, so x over 2, right? Or 1/2 x, either or. Okay, but when we're multiplying the bases, like on the right side here, 3 times 3, then we add our exponents over here. So it's going to be 3 plus 1/2. This is 6 over 2, right? 6 over 2, 1 over 2, so it'll be 7 over 2.
Oh, wouldn't that be 9?
No?
I mean, how do you understand it? Yeah.
Okay, we got 3 to the x over 2 here equals 3 to the, what's the common denominator if I'm going to add these two fractions? It's going to be 2. So I multiply this by 2 over 2, and I get 6 over 2. And then I'm going to leave this as 3 to the 1/2. So that's 7/2. Okay, so what's x? 7. All right, try number 6 on your own. Okay, when we do this one, when you set it equal to x, let's do this because they're getting tight in here. 3 to the x equals 3 root 3. Okay, so this is going to be 3 to the x equals 3 to the first and 3 to the 1/2. Then 1 plus 1/2? 3 halves. So x equals 3 halves. Any questions? Okay, let's look at the last few down here. We don't have to say it's equal to x. They give us an x, or I give you an x in some of these. Log base x of 64 equals 2. So we're going to switch it. Should I wait for anyone? Okay. X to the 2 equals 64. What's x going to be? 8. And it's not plus or minus 8, just write 8. It's just a positive. Yeah, well, yes and no. A little bit of this, a little bit of that.
You know how negative and long sides? Yeah, you can.
You can't have a negative right here where the 64 is. Okay, here we go again. 2 to the x equals 64. Switching it up a little bit. Are you sure?
I got, wait, which one?
Pretty sure it's 5.
It's 6.
It's 6. Yeah, 2 to the 5th is 32. So multiply it by 2 again. So x is 6. Oh, okay. All right, switching 3 to the 1.5 equals x. Not a decimal. You got to give me, yeah, you have to work it out. 1.5, isn't that 3 over 2?
It's 5 point.
No. Stay with me here. 3 to the 3 over 2. Up top is the power or the root?
Power.
Power over the root. Okay, so it's going to be the square root of 3 cubed. I have 3 3's under there. If it's the square root, how many do I get to pull out? It's really 27. So it's 9 times 3. So I'm going to pull out, this is what I'm doing. It's 3 squared times 3 to the first. So what's the square root of 3 squared? 3. And you have a square root of 3 left. The 1.5 to the 3 halves?
The power over root.
Hold on, let KK talk to me. Oh, right here. Okay. When you have a fraction in an exponent, the top is going to be your power, and the bottom is going to be your root. The power is what you're taking it up to, and the root goes on the outside here. We normally don't write the square root, but I just put it there because I thought it would help you guys. Okay, let's do the next one. 1/3 to the negative 2 equals x. 1/3, all of it to the negative 2 is x.
So if it's negative, you flip it.
Exactly.
3 squared.
That's exactly what it's going to be. It's going to be 3 over 1, or just 3, to the positive 2. And 3 squared is 9. Yeah, negative exponents just mean things are in the wrong spot. And then we have log base x of 8 equals negative 6. X to the negative 6 equals 8.
That's gonna be a huge number, isn't it? No?
No. Okay, to get rid of this exponent, what I'm going to do, I want to figure out what this number is over here that x equals. So to get rid of it, I'm going to take both sides to the reciprocal power, negative 1/6. It has to have the same sign because I just want it to be positive 1. So negative 1/6 on both. So I just have x on the left now.
Wait, you're multiplying it by the power of negative 1?
You're taking it to a power. So you multiply these two powers when you take a power to a power, and it just becomes 1. Okay, so 8 to the negative 1/6 means that this negative means I'm going to flip it. So let's do that first. 1 over 8 to the 1/6. Now we have power over root. And no matter what I do to 1, it's always going to be 1, right? 1 times 1, square root of 1, 6th root of 1.
6 of 8.
And now this is going to be, the 6th root of 8. Okay, now we're not done. We can rewrite 8 as what to a power?
2 to the 3rd.
2 to the 3rd. Yep. 1 over the 6th root of 2 to the 3rd. Think about that again now. 3 over 6 is what? 1/2. So it's just a square root. So we've reduced this down to 1 over the square root of 2. But shouldn't we rationalize it?
How did you get, so 100.
I'll answer in just a second. Let me finish this and I'll get to all your questions.
So let's go to 2 over 2.
Square root of 2 over 2 is what x is. All right.
So whenever you have,
Yeah, I'll answer. Let me just quit this and then I'll answer your question.
just